back with our classes on alcohol, phenols and ethers. We studied all the reactions of phenol. The most important reactions of phenol are the special reactions of phenol, which is pole-based reaction, where you react phenol with carbon dioxide to get salicylaldehyde. The second reaction is Riemann-Diemann reaction, where you react phenol with chloroform. I even taught you one more with carbon tetrachloride to form salicylic acid. We studied the formation of salicylaldehyde and salicylic acid. We also studied how to get benzene from phenol. Now we have to study in the end. This is the last topic of alcohols and phenols, and after doing this we will move on to ethers. So we have to talk about acidity of alcohols. First we will talk about acidity of aliphatic alcohols. We talk about what? Acidity of aliphatic alcohols, and after that we will talk about the acidity of phenols. See, what is acidity of any compound? Any compound's acidity basically says that if I have taken ROH, it should be able to easily give what? RO minus and give what ion? H plus ion. Then the substance is said to be acidic in nature. Any substance which gives H plus ion or hydronium ion, because you have studied in 10th that the H plus ions is not capable of independent existence. But as we take lower alcohols, which are generally liquid in nature, one second. So now we know that the alcohol should be acidic in nature because it gives what? H from the OH, and it gives it in the form of what? H plus ions. Alcohols are aliphatic alcohols are weaker acids than water. Please write, alcohols are weaker acids than water. Alcohols are weaker acid than water. How we come to know? You have studied something called as conjugate acid and base. You know here this is the part of alcohol. So if I take the alkoxide ion and I react it with HOH, it forms what? It forms what? This gives H plus. So it forms what? ROH plus what? OH minus. Fine? If this is what? If as water is, how do we write conjugate acid, conjugate base? Which concept of acid and base are we talking about? Lowry and Bronsted concept of acids. So if this is a base, this is an acid because it has donated H plus. This is a base. Reverse reaction, what is happening? This is giving an acid and this becomes what? Base. So please write this equation and then we will further write. Please write RO minus plus H2O gives ROH plus OH minus. This reaction shows that water is a better proton donor than alcohol. Water is a better proton donor than alcohol. Because alkoxide ion is a better proton acceptor than hydroxide ion. Alkoxide ion is a better proton acceptor than OH minus ion. Which shows that alkoxide are stronger base. Which shows alkoxide is a stronger base. Okay? Now understand what we proved. What did we prove here? That alkoxide is a strong base. Why it is a strong base? Because it is easily acid is what? ROH, isn't it? So if the base is strong, its acid has to be weak. So alcohols are weaker acids than water. Understood how we did? We reacted the alkoxide ion with water and found that this alkoxide ion easily accepts the proton given by the acid. So this alkoxide ion is very, very strong. If the alkoxide ion is strong, its base is weak or its conjugate acid is weak. So that is why ROH is a weaker acid when compared to water, as water gives very easily proton to the alkoxide ion to make it a stronger base. Understood till here? Now let us talk about the order of acidity of primary, secondary and tertiary alcohol. By the way, order of acidity of primary, secondary and tertiary alcohols. Please write. This is what alcohol? Primary alcohol. This is what alcohol? Secondary alcohol. And this is what alcohol? Tertiary alcohol. All of you know one alkyl group, primary alcohol, two alkyl groups, secondary alcohol, and three alkyl groups, tertiary alcohol. So the order of acidity is primary, greater than secondary, greater than tertiary. Please write. This is because the electron releasing group, bracket alberin plus I group, the electron releasing group or the plus I group, please understand here, plus I groups are what? Alkyl groups, CH3, C2H5, they are all electron releasing group, or they show what effect? Plus I effect. These electron releasing group or the electron releasing group increase the electron density on the oxygen, tending to decrease the polarity of OH bond, which decreases the acid strength, Now let us understand what you have written. Okay, it looks very complicated when you write. So let us understand here. I have CH3, CH2, OH. Okay, I will make this OH like this. Here I have CH3, CH3, C with an H and OH. And here I have CH3, sorry, I have C, I have CH3, CH3, CH3 and OH. This is how my reaction looks like. Correct? Now, this is an electron releasing group. You know, inductive effect is valid till 3 carbon atoms. So this is an electron releasing group. This releases all the electron over this carbon atom. This carbon atom further pushes it towards the oxygen atom. Oxygen already has what? Lone pair electrons. So the electron density over this oxygen atom increases a little bit because it has only how many group? One alkyl group, and the strength or the polarity of the OH bond is slightly disturbed, but then this OH bond can easily break and give H as H plus ions. Correct? Now let us understand here. It has two alkyl groups. All the alkyl groups release their electron towards this carbon atom. This carbon atom becomes electronegative or it becomes electron rich. So it moves it towards what atom? Oxygen atom. The more electronegative oxygen atom becomes, the more it holds the H bond towards itself, because H is the positive center. So it pulls the H towards itself. So it will not easily H plus, and hence the acidic strength decreases. More number of alkyl group tend to increase the electron density of the oxygen atom rapidly or very strongly. As a result of it, this H cannot be removed in the form of H plus, as oxygen is highly now electronegative and has a large electron cloud over it. So it will not let this bond to break and remove it in the form of H plus ions. So the reason of decrease in acidic strength from primary to tertiary is because of plus I effect, or the electron releasing group of alkyl groups, or the electron releasing group. Clear? So aliphatic alcohols are not strong acids. They are weaker acids than water, because their conjugate base alkoxide ion is stronger. So alcohol is weaker acid than water. The order of acidity of primary alcohols is in the order primary greater than secondary greater than tertiary. This is because of plus I effect, as the alkyl group present show plus I effect, or they are electron releasing group, which increases the electronegativity over the oxygen atom, or the electron cloud over the oxygen atom, and hence removal of H in the form of H plus ions becomes difficult. More the number of alkyl group, more stronger is the plus I effect, and weaker becomes the acidic strength. Okay, now write heading acidity of phenols. Acidity of alcohol clear? Now we will write what? Acidity of phenols. Please write acidity of phenols. Please write first question. Why are phenols more acidic than aliphatic alcohols? Why are phenols more acidic than aliphatic alcohols? Okay, so now let us understand here. I have an aliphatic alcohol ROH. This ROH ionizes as RO negative and H plus. This hydroxide ion is not stable, and hence it is not stable because it does not show any resonance. It is not a conjugate system. So it immediately combines back to form what? ROH. Whereas in phenol, if I take, this is phenol, and this phenol, when it breaks into what? Phenoxide ion. This phenoxide ion can show resonance because it is what system? A conjugate system. There is an alternating double bond, alternate double and single bond, and there is also a lone pair electron. So this phenoxide ion stabilizes due to resonance. It stabilizes due to resonance, and hence it can have a large H plus ion in the solution, and hence phenols are more acidic than aliphatic alcohols. Correct? Right. First write this equation. ROH gives RO minus plus H plus. Please write. Due to higher electronegativity, please write the alkoxide ion is not stable and hence it combines back with the proton to form alcohol. It combines back with the proton to form alcohols. Hence, aliphatic alcohols are less acidic. Hence, aliphatic alcohols are less acidic. Understood this part? Now write the next equation. C6H5OH gives C6H5O negative and H plus. This also make it a reversible arrow because they are all weak acids. C6H5O negative plus H plus. This is what ion? This is alkoxide ion. This is what ion? This is called as phenoxide ion. Alkoxide and phenoxide ion. Written? Now write please. In phenols, the phenoxide ions is highly stable as it is resonance stabilized, or as it shows resonance. Second point, due to higher electronegativity of sp2 hybridized carbon, sp2 hybridized carbon of phenol, to which OH is attached, electron density decreases on oxygen. Electron density decreases on oxygen, which increases the ion polarity of OH bond, which results in increasing ionization. Which results in increase in ionization of phenol. Thus, there are more H plus ions in solution and therefore phenols are more acidic than aliphatic alcohol. Hence, phenols are more acidic than alcohol. Is it clear? The second question, that why is aliphatic alcohol less acidic and phenols more acidic? So you have studied things that this is not resonance stabilized, this is resonance stabilized. Resonance stabilized also can be written as that there is delocalization of electron here, but here there is no delocalization of electron. Then this carbon, which is sp2 hybridized. Why it is sp2 hybridized? There is presence of what bond? Double bond, due to which the electron density over the oxygen atom increases, which increases the polarity of the OH bond, which results in the breakage of OH bond. According to Le-Chatelier's principle, if any system is in dynamic equilibrium and there is more of ionization or more of product formed, what happens? It will lead to further ionization. So there will be more of what ions? H plus ions in the solution, and hence phenols are more acidic than aliphatic alcohols. Now the third question is right. Which is more stable? phenol or phenoxide ion. Phenol or phenoxide ion, which is more stable. Okay, so for this, when we are talking about phenol and phenoxide ion, you need to write the resonance in both. Okay, so first thing, when we are talking about phenol, we will write resonance in phenol. Kindly do the resonance in phenol. So this is C6H5OH. It has oxygen has 2 lone pair electron. Bring the lone pair electron, break the bond. Draw all resonating structures of phenol. So you will have double bond OH. You will have a positive charge. You will have a negative charge here and here. Then you have this and this bond breaks. So you get double bond OH. This comes here and this breaks. This is what is resonance in phenol. Okay. Now we will talk about resonance in phenoxide ion. Phenoxide ion is what? C6H5O negative. How many electrons? Lone pair on it. On O negative, how many lone pair electrons? 3 lone pair electrons. So this goes, this comes. So please draw the structures now. Double bond O. You will have a positive charge here. You will have 2 lone pair electron, and you will have a negative sign here, and you will have a structure like this. This further goes as this is how you will have resonance hybrid in phenol and phenoxide ions drawn. Please check, this is for phenoxide ion and this is resonance. The last one, if you can see, this is resonance hybrid. Amoxite, can you see it here? It is the resonance hybrid. Let us number these structures or number them as 1, 2, 3, 4 and 5. Number your structures as 1, 2, 3, 4 and 5, leaving aside the resonance hybrid. Sorry. Now write in phenols or in phenol structure 2, 3 and 4 show in phenols structure 2, 3 and 4 show that charges are separated and the most electronegative oxygen atom and the most electronegative oxygen atom carries a positive charge. Okay? Right. These two factors destabilize the phenol molecule. These two factors destabilize the phenol molecule. Now look, I have drawn something and then I'll tell you why we did it wrong, because all of you would have done like me only. Okay? What did we say here? We said in phenol molecule, structure 2, 3 and 5 show that there is charge separation. Don't they show there is a positive charge, there is a negative charge, isn't it? So there is, in this structure there is no charge separation. But in structure 2, structure 3 and structure 4, there is charge separation. The electronegative oxygen has got a positive charge, and wherever the bonds have been broken, there is what charge? Negative charge. So these two factors destabilize the phenol ion and make it less stable. Now let us come to phenoxide ion. Phenoxide ion, look here, phenoxide ion has 3 lone pair electrons. Please look. When you remove and transfer one lone pair electron, we have all written positive charge, but this does not acquire a positive charge. There should be no positive charge, okay? Because it has got the extra electron. That extra electron, it is sending it as the conjugate system. It has not lost any electron. So if you have written positive charges, please remove it, because that is wrong. Okay. So what we say in phenoxide ion, in structure 1, 2, 3 and 4, there is no charge separation. Please write. In phenoxide ion, there is no charge separation and the negative charge of oxygen is delocalized in the benzene ring. Hence, phenoxide ion is more resonance stabilized than phenol. Hence, phenoxide ion is more resonance stabilized than phenol. Arthaita. In structure 2, 3 and 4 of phenol, there is charge separation, as well as the electronegative oxygen gets a positive charge, which destabilizes the phenol molecule, and hence phenol is less stable. In phenoxide ion, there is no charge separation, and the electron basically gets delocalized in the benzene ring, which gives stability. As we know that one of the most important aspects of delocalization or resonance is stability. Hence, phenoxide ion is more stable than phenol. Now the next question, please write. What is the effect of substituent on the acidity of phenol? Please write. Effect of substituent on the acidity of phenol. Effect of substituents on the acidity of phenol. We have studied one thing in aliphatic alcohols. We have studied that any group, which is what group? Electron releasing group. Electron releasing group or quasi-effect group, which is what? CH3, C2H5, they all decrease the acidic strength. Yes or no? We studied, that is why we said that tertiary alcohol is what? Less acidic than secondary or primary alcohol. So we know electron releasing group on the benzene ring will also decrease the acidic strength of phenol. Next, what is the group? Electron withdrawing group, such as NO2 will what? Will increase the acidic strength. Is right. Will increase the acidic strength of phenols. Will increase the acidic strength of phenol. Okay, now one more thing. When I am trying to place these groups, please look here. When I am talking about electron withdrawing group, the effect is more pronounced when the group is at what position? Ortho and para position. Why it is more pronounced when ortho and para position? Because the electron density increases at ortho and para position. So how is this question asked? Why is ortho-nitrophenol or para-nitrophenol more acidic than meta-nitrophenol? In meta position, there is no electron density increase in phenol. So if you place a nitro group in meta position, it will not affect the acidity of phenol. But if I place a nitro group at ortho or para position, because in phenol after resonance you know the negative charge increases only at ortho and para position. So we should always place the electron withdrawing group at ortho and para positions. Please write. The electron withdrawing group should be placed at ortho and para positions as the electron density increases at ortho and para positions. Ortho and para positions. Is it clear? Understood? So, if the question asked to you is, why is ortho-nitrophenol more acidic than phenol? What will you write? Please write the question, why is ortho-nitrophenol more acidic than phenol? Or, why is para-nitrophenol more acidic than phenol? More acidic than phenol. Answer no. Ortho or para-nitrophenol contains an NO2 group, which is what group? Electron withdrawing group, which stabilizes or which increases the acidic strength of phenol. You can write your own answer what you want. Okay? If you have understood the concept, you will write. But if it is present at meta position, it basically will not have any effect. Okay? Now please look here. You open your textbook and see table 11.3. Table 11.3, very important. Okay, what does it indicate, table 11.3? You have compounds and these compounds have their formula and their pKa value. Please look here. What is pKa? It is negative log Ka. Okay, so higher the pKa value, higher the pKa value, lower is the acidic strength. H3 means it is a strong acid. अच्छा आपका idea? What is pKa? It is negative log Ka. What is value of Ka for strong acid? It is 1. For Kb, for a strong base, it is 1. Okay. But what happens when you have weak acid? Its degree of dissociation alpha is less. Whatever we are studying in second book, they are all weak acids. I cannot compare phenol to HCl's acidic strength. Phenol, carboxylic acid, they are all what? Weaker acids. So we need to know their Ka values. If the Ka value is more, it's because it is a negative log, its Ka value is more, so its pKa value has to be less. So higher the pKa value, lower is the acidic strength. Will not put it. First see ethanol. Ethanol's pKa value is 15.9. which is very, very large. So ethanol is a very, very weak acid compared to para-cresol. Cresol is what? Cresol is methyl phenol. Okay, cresol is methyl phenol. This methyl group is what group? Electron releasing group. Electron releasing group will decrease the acidic strength. So see the value, it is 10.2. Then metacresol 10.1, orthocresol 10.2. So all cresols are what? Weaker acids than phenol. Phenol's pKa value is 10, whereas cresol is 10.2. Now go to orthonitrophenol or paranitrophenol. See the value is 7.2, 7.1. That means they are very strong acids. Meta also is better than phenol. Any electron withdrawing group is better than phenol. So if they give you the acidic strength, you should know which is plus I group and which is minus I group. All minus I groups are electron withdrawing groups. All plus I groups are electron releasing groups. All electron releasing groups will bring down the acidic strength of phenol. All plus minus I groups will increase the will increase the acidic strength of phenol. If the pKa value is more, acidic strength is less. Is it clear? So this is all about acidity of phenols. Kindly do example 11.4. Kindly do example 11.4. Tomorrow we will take a class on ethers. Thank you.